Ever wondered how AI can learn to recognize something new without being shown thousands of examples? Like, say, identifying a rare medical condition from just a few images. That's where a groundbreaking new model called PictSure comes in, and it's changing the game for AI in healthcare, agriculture, and beyond. Let's start with the big challenge. Traditional AI models need massive datasets to learn. Think of it like teaching a kid to recognize animals by showing them 10,000 pictures of dogs and cats. But what if you only have 5 photos of a rare disease? That's where few-shot learning steps in, training models to learn from very few examples. Here's the twist. Most of these models rely on text labels to guide them. PictSure, it's different. It skips the labels entirely, letting the AI learn from the images themselves. Imagine showing a model a bunch of pictures of tumors, and it figures out patterns on its own. No, this is a tumor prompts needed. That's the power of in-context learning. So how does it work? PictSure uses a clever setup. A transformer, a super smart pattern recognizer, paired with a vision backbone like ResNet or a vision transformer. But here's the secret sauce: image embeddings. These are mathematical snapshots of what an image looks like to the AI. PictSure focuses on making these embeddings super robust, even when the data is messy or unfamiliar. The researchers tested this by training PictSure on 14 million images across 21,000 categories. Then they threw it a curveball: blurry images, distorted details, and completely new tasks like spotting bone fractures. The result? PictSure outperformed other models like CAML and KNN, especially in medical datasets. Why? Because it didn't rely on fancy semantic spaces or text clues. It trusted the raw visual data. Here's what really stood out. PictSure's success hinged on pretraining. By locking in the image encoder, the part that analyzes photos, and letting the transformer focus on task-specific patterns, the model stayed stable even when faced with unknown challenges. It's like giving a musician a trusted sheet of music and letting them improvise. No need to rewrite the notes. And the best part? PictSure is smaller and faster than many competitors. It's proof that quality over quantity matters in AI. No more waiting for huge datasets, just a few examples and the model figures it out. But how did they even build something this powerful? Let's dive into the experiment. Researchers didn't just train an AI model all at once. Instead, they split the model into parts and trained them separately. Think of it like learning to drive. First, you master the basics: steering, braking, then add more complex skills: parallel parking, navigating traffic. In this case, they locked the encoder, the part that processes raw images, so it couldn't change during early training. Then they let the rest of the network learn on its own. Why? To test if the model could grasp the fundamentals before tackling trickier details. The setup: a single supercomputer GPU, basically a high-powered version of the graphics card in your gaming PC. They ran 600 training rounds, each with 10,000 images. But it wasn't just about brute force. They tweaked tiny settings like weight decay, which stops the model from memorizing data instead of learning patterns, and label smoothing, a way to handle images that don't fit perfectly into categories. These adjustments are like fine-tuning a recipe. Small changes can make the final dish way better. The big takeaway: even minor shifts in how you train an AI can supercharge its performance. Whether they used ResNet, a classic image recognition model, or ViT, a newer transformer-based approach, each tweak brought them closer to smarter, faster, and more reliable visual AI. So the next time you hear about AI diagnosing diseases or spotting crop issues, remember, innovations like PictSure are making it possible to learn from almost nothing. Thanks for watching, stay curious, and let me know what you think in the comments. Stay tuned for more deep dives into the future of AI. Until next time, keep exploring.